For last lesson and the lessons before that, and in fact even going back to year 9 algebra, when we've solved for x, we've often had to do that by rearranging equations and putting all the x's on one side, all the other numbers on the other. Well, what does it really look like? What are we actually trying to solve? And one of the things that we try to do when we solve is, you might remember from the linear equations, a thing called x-intercepts. Finding the x-intercepts of a particular graph is the same as solving for x, because the x-intercepts, well, that will be how would you normally find the x-intercept? Put your hand up if you remember a linear equation. When you want to find the x-intercept, what do you normally have to do, Mr. Schwab? You make y equals 0. So when we've been solving quadratics yesterday, we had everything, so, we've been doing like these quadratics, x squared plus 12x minus 3, we've been making them all equal to 0. And so that's why when you're solving a quadratic, you're finding the x-intercepts. So I want you to know that the word solutions, x-intercepts, solving for x are all the same kind of thing. So if you need to find solutions to the question, or you need to find x-intercepts, or you need to find, if you're solving for x, they all mean the same thing. Because they involve an x squared, or taking the square root of something, in calculators they can be referred to as square roots, or just roots, one of the two. So, to solve for x when it comes to graphs is literally just as easy as looking at where the graphs hit the x-axis. So if I want to solve for x, so for instance in this one down here, this one that says we've got x squared plus x minus 20, we can see here that one of the x-intercepts is here and the other one is over there. So literally it is easier saying that if I'm solving for x, is it 4? Okay, sure. Which one's 4? Sure. Top. Thank you. That would make sense. Sorry. There we go. It's a 4. And so finding the solutions to this equation is as a matter of just looking at these and going, well, x is -5, x is 4. Look at all that strenuous hard work I've had to do. That's it. So finding the x-intercepts is as easy as that. So similarly, wait, what?
Doesn't it say 2 solutions?
Yes, that's 2 solutions. So 2 solutions is the same as saying 2 x-intercepts or 2 answers. Quadratics that have 1 solution would be if they have 1 x-intercept, or ideally you'll see here, and so this one, I think on my graph, it's a 2 there. Yep. So therefore, that's literally the answer to solve that quadratic, is x equals 2, and done. And why is that? If I was to factorize, can anyone factorize what this one would be? What would be x squared minus 4x plus 4 in brackets? X minus 2, x minus 2. Because -2 times -2 is +4. -2 plus -2 is -4. And so that would be the same as saying x minus 2 squared. So there is only going to be 1 solution. Now, at the bottom of this sheet, you'll also see an example of a quadratic that has no solutions.
X equals 0.
Yeah, well, not even that. This quadratic here has no x-intercepts. It is unsolvable. No matter if you use the quadratic formula, completing the square, anything like that, it is unsolvable. So there are no solutions.
We get any of those questions in the test?
Sorry? Well, something like, if you need to find something that has no solution, yes, you might get a question like that where you have to see whether or not a quadratic has a solution. Luckily, there is a quick and easy way to determine if something has a solution, which we'll talk about very shortly. But from a graph point of view, that's a very easy way. There's no solutions because the graph does not hit the x-axis. Because there is no x-intercepts, because the graph doesn't go to the x-axis, it has no solution. Yes, Mr. Schwab.
That was hypothetically the test. Would you get a mark if you just wrote no solution?
Yeah, that's fine. If I was to tell you what are the solutions to this and you wrote none, that is correct. There are no solutions because it doesn't hit the x-axis.